another. To understand these rules, we first need to talk about valence electrons. Valence electrons are the electrons in the outermost shell of an atom. These are the electrons that participate in bonding. Now, let's discuss the octet rule. The octet rule states that atoms tend to gain, lose, or share electrons to achieve a full outer shell of 8 valence electrons, which is the same electron configuration as the nearest noble gas. This configuration makes the atom stable. Let's look at examples of elements that follow the octet rule. Sodium has 1 valence electron. Chlorine has 7 valence electrons. Sodium can give its electron to chlorine, forming a sodium ion with 0 valence electrons and a chloride ion with 8 valence electrons. Elements can also share electrons to satisfy the octet rule, forming covalent bonds. For example, 2 chlorine atoms can each share 1 electron to form a Cl2 molecule, giving each atom 8 valence electrons. Now, let's move on to the duplet rule. The duplet rule applies to hydrogen and helium. These elements achieve a stable configuration with just 2 electrons in their valence shell. Like helium, helium is stable with 2 electrons in its first and only shell. Let's see how hydrogen follows the duplet rule in bonding. Hydrogen has only 1 electron in its valence shell. 2 hydrogen atoms can share their electrons to form H2, giving each atom a complete duplet like helium. Now, let's see both rules in action with water, H2O. Oxygen has 6 valence electrons and needs 2 more to complete its octet. Each hydrogen has 1 electron and needs 1 more for its duplet. By forming 2 covalent bonds, oxygen gets an octet and each hydrogen gets a duplet. Let's summarize what we've learned. The octet rule states that atoms tend to gain, lose, or share electrons to achieve 8 valence electrons. The duplet rule is followed by hydrogen and helium, needing only 2 electrons for stability. Both rules explain how atoms bond to form stable molecules. Understanding the octet and duplet rules helps us predict how atoms will bond and form compounds. These principles are fundamental to chemistry and provide a framework for understanding countless chemical reactions and structures.